Alright, so this stuff is how geometry works, right? The underlying reason that geometry functions. Now, do you see something up there that makes sense to you? Is any of that new information?
Because it has like the if and then.
So when I talk about the addition property, what am I really talking about? What does the addition property state?
If A is equal to B, then A plus 5 is equal to B plus 5.
Okay, yeah, but you're reading. Is that cleared up?
Let me see.
What does that mean though? Like, you heard it before, you've said it a million times. It says if A equals B, then A plus 5 equals B plus 5. What did I do there? Add 5 to both sides. So the addition property states, like you have to keep it the same. So if it's A equals B, then it should make sense that A plus 5 equals B plus 5. Is the equation still balanced? Yeah. So the addition property states, add 5 to both sides. Could it be add 6 to both sides? Yeah. So then the subtraction property says the same thing. If you have A equals B, then A minus 5 equals B minus 5. What did you do there? You subtracted 5 from both sides. Have y'all heard this stuff before? Alright, so you'll see that somewhere on your paper right here. There's a bunch of boxes, and it says, use the word bank at the top to identify which property is down there. So what do you think that first box says? The first box says, if A equals B, then A plus C equals B plus C. That's the addition property. What did we add to both sides? Please, 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 you have to write the addition property of equality. These are all equality properties because what is that big sign connecting the terms? An equal sign, because there are also properties of congruence. So you can abbreviate and put POE for property of equality. What about number 2? It says if A equals B, then A divided by C equals B divided by C.
Division property.
That's the division property of equality.
So would you put DPOE?
Division, POE. Number 3.
Symmetric property.
No. Number 3, it says 12.5 equals 12.5. That's the the reflective property of equality. See what I did there? Reflective reflection. It's a reflection of itself. That's the reflective property of equality. So you have to put reflective, POE. That's got to be in there. Yeah, it's the third one down. The reflexive. And you're confused because I said reflection, right? And reflexive and reflection mean kind of the same thing. Ooh. If A equals B and B equals C, then A equals C.
Substitution.
No. Did someone say syllogism? Because that is like syllogism, isn't it?
Yeah. Would it be transition?
But now it's called the transitive property. That's why they call it the train rule. Because if A goes to B and B goes to C, then A goes to C. It's called the train rule or the transitive property of equality. Transitive property of equality. Okay, then Andres already kind of hit this one. If A equals B, why does B equal A? That's symmetric, right? They are symmetric to each other. There's a line of symmetry between those two expressions. The symmetric property of equality. Number 6, it says if A equals B, then A times C equals B times C. Multiplication, property of equality. Oh no, everyone's ID numbers are on the internet now. Okay. Oops. Number 7. It says if 3 times 12 minus 4 equals 3 times 12 minus 3 times 4. That's called the distributive property. And it's weird because they're just showing you what they're distributing. You're kind of like showing your work. The distributive property of equality. Yeah, it's distributive property. Because there is no distributive property of congruence. So the distributive property. Number 8, what is that one?
Subtraction.
Subtraction property of equality. POE. And number 9 gets you guys every time, all the time. Y'all know what it is, but you don't know how to say it. If A equals 4 and 6A plus, why does 6A plus 2 equal 6 times negative 4 plus 2? Because you're substituting in a negative 4 for where A used to be. That's one that always trips you guys up. So those are tools that you will use during proofs. So I'm going to skip past some of these that you may or may not already know. Guys, the distributive property can look a lot of different ways. What would the distributive property say for the first one?
We got 2x plus 14.
No. You can't math. You just have to apply the property.
Distributive POE.
2x.
The distributive property states it's 2 times x plus 2 times 7. Weird, right? I know the answer is 2x plus 14. Y'all get that. But identify what the property states. Okay, you don't have to write this stuff down. This is the stuff we're going to practice. Now, what would the distributive property state for this?
6 times x minus 6 times
So you're undistributing now. That's like called factoring. This is 6 times x plus 3.
Wouldn't it be
Oh, you're right. You're undistributing it. And does it matter that this goes backwards here?
No.
So it's just 4 times x times 4 times x minus 4 times negative 3.
Wait, would it be minus 4 times negative 3 or would it be plus?
It would be 4 times x. Oh yeah, I guess it would be plus 4 times. I mean, that's semantics there. Either way, take it to your right. Okay, so then here's your first example of what would a 2-column proof would look like.
Do you want us to write this down?
No, not this one. Yeah, I don't want you to write and miss the purpose of what's going on here. So, in a 2-column proof, it's called a 2-column proof because there is 2 columns. Right? The first column over here is going to be your reasons column. Okay? The second column over here, this is going to be your statements. Statements over here is called reasons. So, the statement 5z minus 2 equals 23. Why is that statement true?
Because 5z equals 25.
But why? You guys have
Because
never
if you-
heard this before.
The 2 to the 23.
Why is it true? Because I gave it to you. Generally, your first reason will always be given. That's something you guys need to start being aware of. Why is the first statement true? Because I gave it to you. That's why it's true. I'm never wrong. So, here's where you actually have to start mathing for yourself. Why is 5z equal to 25 now?
Because you subtracted 2.
I subtracted
Or
2.
you added 2 to
The addition property of equality. I added 2 to both sides. Now, work is not being shown here. You're justifying each step. This is why this is true. Why is z equal 5 now?
division property.
Because of the division property of equality. Guys, that is your first 2-column proof. You're just explaining why statements are true. Don't write this one, let's watch this one. Why is the statement 5 times x plus 2 equals 20 true? Given. Now, why is 5x plus 10 equals 20 true? And then why is 5x equal 10? And then does this seem like a cakewalk for you guys? You're just explaining what algebra is taking place. I'm hoping it's confusing. Alright, I want you guys to write this one down. I'll give you a little bit of time because you gotta write all of that. And realize that I am not showing my work here. I'm asking you guys to justify step 1 to step 2 what took place. Now, something that's huge for you guys, do you have to know all the steps in all the right order to receive credit for this? No, because it's fill in the blank, each blank has its own assigned point value. So if you got here and didn't know what the answer was, and you skipped here and got something, and then you didn't know what it was and skipped here and got something, you're filling in blanks that you know. It means you're proving knowledge. Don't just assume that you have to know all the steps, because there is a test in this class that's going to be 6 proofs. All of it, just blank. And the more you write, the more credit you get. If you just say, oh, I don't know, and you leave it blank, and then it's just -2, -2, -2. There's 50 blanks on there. And there are 2 points of blank. And I've had people just leave a whole proof blank, and that's already -14 points. Don't leave things blank if you can somewhat justify what you know. Why is statement number 1 true? Given. Now, is anybody a little confused about why statement number 2 is true? No? Multiplication. So they multiply both sides by 3, or the denominator. Alright, then what happened? A distributive property. Ooh. Huh? The addition, property of equality. And then the division, property of equality. Are y'all kind of understanding the process here? I hope you are, because when it gets to geometry stuff and some of your reasons are the segment addition postulate, or the definition of a midpoint, or the definition of an angle bisector, tools that you guys are not comfortable using, it's going to get weird. Yeah. Alright. Don't have to write this one down, but we're going to talk about it. Oh, here, I'm just going to baby step you into this. Surprise! We're doing geometry right now. Why is this statement true? No.
Because B is the midpoint. Reflect.
Okay, because B is the midpoint. So how do you write that in geometric terms? Can you write midpoint?
No, you add one.
Ready? Why is this piece equal to this piece? Because the definition of a midpoint says that it is.
So you would just like that.
Yeah. And you guys knew that. Hey, it's a midpoint, but you don't know how to write it. The definition of a midpoint states that this piece equals this piece. And how did you know that B was the midpoint?
Because B equals C. B is a total.
Because of these congruent marks right here. Those congruent marks state that B is a midpoint. So then there is actually steps to this proof missing. Right? So I know for a fact that those two pieces are equal. Now, because AB equals BC, definition of a midpoint, now how is this true? How did they skip from geometry to algebra? And I plugged it in is not a reason in geometry.
Given.
Nope, it's not given. Substitution property. I subbed out the geometry and I subbed in the algebra. That's called the substitution and you guys are like, oh, I get that. I knew that was the answer. You just didn't know how to say it. Once you see it, you're like, oh, duh. And I told you that's the one that always gets you. What next?
Subtraction.
Then you get comfortable. Subtraction property of equality. If you're going to abbreviate, make sure you abbreviate enough to where I know the difference between substitution and subtraction. You can't just put sub. It means different things to me. Then what?
Subtraction. Yeah.
I'm going to do that right now, but you can't do that on your test. Sucks for you. Then what?
It's a given.
And this is great, guys. All the math is already done for you. You just have to explain to me what's going on. And then I like to give this one to check you. No. Guys, these are the easy ones. I don't like to use the E word. These are the easy ones. They are only going to get more complicated than this. And we're going to scrub the algebra from all of our proofs, and it's just going to be geometric stuff. Here we go. Why is that first statement true? I hope you're terrified. Okay, so you saw this and you were saying addition, right? What are you adding? So what do you call that thing when you add segments together?
Segment addition postulate.
This is true because of the segment addition postulate. I know I taught that to you. The segment addition says the first piece plus the second piece equals the whole thing. I'm making you guys use brand new tools right now. Okay? If that's true, because the segment addition postulate, why is this true? Oh, look at us doing it. Substitution property of equality. And then
Subtraction. Addition. Oh no.
what?
You said this one before, but I don't know.
Sucks for you.
The next one's division,
Okay.
but then the one
It's
after that.
reflexive.
Oh yeah.
when you look in the mirror, when 5 looks in the mirror, does he see in?
No.
That's the reflection, right? That's the symmetric property. So now I talked to you guys about this. 5 equals in is right, but it's weird. We like to make things really correct in geometry. Why is this true? Because the symmetric property of equality. And that one has to be POE or it's wrong. Because you might say symmetric property of congruence, and that is not true. Because there's an equal sign right there. Oh, you guys are terrified right now. Please don't be. I think I'm really good at this. I like to be over stringent. Okay, so we're done with that stuff right now. You can kind of clear your desk. I'm going to spend the last 15 minutes talking about your project. Now, if you want to take notes on this, yeah, it might help you. Or you just want to watch, it might help you. So I'm going to skip quite a few steps here, and I'm going to get to the part of your project where it looks like this. At some point in your project, you should have a line that looks like this.